Hi you guys, welcome to today's lesson. Today we're going to talk about the 30, 60, 90 right triangles and their side lengths. Now if you've already watched the 45, 45, 90, it kind of works similarly to that one. So before we get to that, just like the other one, we're going to do a little warm-up with radicals. Remembering that numbers out in front get multiplied together, we assume a 1, and numbers underneath get multiplied together. So I get 2 out in front, and 3 times 5 is 15. And root 15 is not as simplified as possible, so 2 root 15 is your answer. So root 6 times root 2, we get root 12, and 12 is 4 times 3, but the square root of 4 is 2, so 2 comes out, and that 3 stays over underneath. I can throw that integer out in front, so I get 3 times root 6 times root 2, so 3 root 12. Again, 12 is 4 times 3. Square root of 4 is 2. There's already a 3 out in front, so 2 times 3 is 6. And I get 6 root 3. And then the important runner here, rationalizing again, we've got 5 over root 3, so we multiply the top and the bottom by root 3, so we get 5 root 3 over 3. Now, I'm hoping that you can pick up very quickly when I've got an integer over that radical 3. So if I've got 4 over root 3, it jumps right to 4 root 3 over 3. That'll become important later on. So a good little review for the radicals. So your 30, 60, 90, unlike the 45, 45, 90, it's got some different tick marks. Angle measures, you'll see a 60 in here, and if remember, angles add up to 180, so 180 minus 90 minus 60 leaves me with 30 up here. The tick marks are going to be different because my sides are not the same, which they were in the 45, 45, 90. And here are your general side lengths for your 30, 60, 90. We've got your hypotenuse, which is 2x. Across from the 30 is x, and then across from the 60 is x root 3. Now the way that I help my students remember this is that the 30, 60, 90, this has the 30-degree angle in there, so we deal with the root 3 typically in these triangles. The 45, 45, 90 has 2 congruent sides, so it had the root 2. So again, 2x across from the right angle, x across from the 30, and then x root 3 across from the 60. So if I jump on down here, here's my 90, so across from there is the 2x in general. Across from my 30 is the x, and then across from the 60 is x root 3. So what I do is I take what's given to me, so the 6 is corresponding to the x right here. So this side is I take my x, which is 6, and I tack on a root 3. So this side is 6 root 3, and then this side, the hypotenuse, is 2 times that x, so 2 times 6 is 12. Let's try that again. So across from the 30 is my 8. I attach a root 3 to it to get my other leg, which is across from the 60. And then my hypotenuse is taking what's across from the 30 and doubling it. Across from the 30, x, and doubling it, 2x. So 2 times 8 is 16. We'll do a couple of those just to get a little warm up. So again, across from the 30, now this time notice the 30-degree angle moved up here, so this is 60 down here. So across from the 30 is 7. Double it to get my hypotenuse, and then I attach a root 3 to get across from the 60. So across from the 30 is 5. Double it to get my hypotenuse. Notice these triangles are going to switch around and turn and change, so pay attention to where the sides are. So double what's across from that 30 to get my hypotenuse, and then I attach a root 3 to get what's across from the 60. Now, this time I gave you the hypotenuse. So when we had the leg across from the 30, we doubled it to get the hypotenuse. So going backward, I'm going to cut my hypotenuse in half. So 6 divided by 2 is 3, and that goes across from the 30-degree angle. And then I still take what's across from the 30 and I attach a root 3 to it to get what's across from the 60. Now that's another situation. Here's a third situation. I actually gave you what's across from the 60 right there. And remember, the general side length for across from the 60 is x root 3. Well, if I look, x is my number out in front, so 6 is my number out in front, which corresponds to what's across from the 30. and then again I take what's across from the 30 and double it to get my hypotenuse, so 2 times 6 is 12. Let's see that one again. Just for repetition matter, there's the 6 root 3 again. So again, we took the 6, we brought it down here, we doubled it to get what's across from the hypotenuse. In this case, there's a 12 out in front, so I steal the 12, that goes across from my 30 degree, and then double what's across from my 30 to get my hypotenuse. Let's try it again. Now it's 19, so take what's out in front of the radical 3, 19 goes here, double 19, and you get 38. This time though, there is no radical 3 attached to what's across from the 60 right there. And remembering that the general side length is x root 3 is equal to 6 right here, so there's no radical 3. So here's the algebra for it. If I want to get x, I divide both sides by root 3, and I get 6 over root 3, which is why we did the rationalizing up above. So I multiply the top and the bottom by root 3. It becomes 6 root 3 over 3, and then 6 divided by 3 is 2. So I'm hoping that you see if you are missing the radical 3, you attach a root 3 over 3 next to it. Sometimes it simplifies, sometimes it doesn't. So then I get 2 root 3 after simplifying. So now I take my 2 root 3 and that goes here. I still double this to get what's across my hypotenuse. So 2 times 2 root 3 is 4 root 3. So then across my 60 I attach a root 3 over 3 to it, which is this. And then I double that, so 2 times 2, I get 4 root 3 over 3. So again, sometimes it simplifies and sometimes it doesn't. Oops, I moved too far. So now again, across my 60 is missing the radical 3, so I attach radical 3 over 3. In this case it does simplify, so 15 divided by 3 is 5, so 5 root 3. And then 2 times 5 root 3 is 10 root 3. Let's try it couple more times here. Get rid of these tick marks. Oop. So now again, this time, jump down over here. Across from my 60 is 21. It's missing the radical 3, so 21 root 3 over 3. 21 divided by 3 is 7 root 3. And then 2 times 7 root 3 is 14 root 3.